All right, good afternoon, everyone. My name is Murad Mukbel, and I'm the director of the Master of Science in Business Analytics here at University of Texas Rio Grande Valley. And I have been actually teaching information systems and business analytics for the past 12 years. So it is my pleasure today to go with you through this workshop. And so today's we are going to go briefly over what business analytics is about, and then we will do a demo through machine learning, artificial intelligence using Orange data mining software. So before we start, what is business analytics? So we want to know what we really mean here by business analytics. So business analytics is used interchangeably with other terms like business intelligence, big data analytics, data science, just to name a few of the terms that are used exchangeably. Artificial intelligence is another term. So at the end of the day, all of those terms actually do the same thing. They transform raw facts, which is data, to useful information. So that way we can, with that information, we can reduce waste, we can improve efficiencies, we can improve effectiveness, and we can, at the end of the day, improve profitability, which is the bottom line, right? So you can think about business analytics as sitting on three pillars. And those three pillars is quantitative methods, which is stats and machine learning, just to name a few. And then the second pillar is information technology, which understanding of the software like Python, R, Orange, just kind of an example, right? And the hardware and the software, right? And then the third pillar is understanding the business context, because we are trying to improve or solve a problem in a business context. So that business context can be either in finance, accounting, healthcare, banking, any industry, as long as that is the business context. So before we go into details about business analytics, let's have a look at this slide, which shows us what goes on in 1 internet minute in 2023. So as you can see, there are more than 241 million emails that are sent in 1 minute in 2023. And you can see more than 22,000 people visit ChatGPT per 1 minute in 2023. So there is a lot of data that is created and stored every single minute. And this increase of data, an exponential increase of data, has far outpaced our human ability to understand this data and make sense of it, right? As a result of this exponential increase of data, a lot of organizations have been struggling to find skilled workers who can help them transform this data to useful information. So as a result, a lot of universities, including our university, actually started new programs like the Master of Science in Business Analytics, so we can equip and train our students with skills to transform data to useful information. And some of the examples of the new roles that have been introduced by those organizations include data analyst, data scientist, AI specialist or artificial intelligence specialist, machine learning specialist, big data specialist, just kind of to name some of the new roles that have been introduced in the market nowadays. And when you graduate, if you graduate from our program or our graduate from our program, will be eligible for any of those titles. So what is business analytics? Business analytics, usually it is in the information systems department or in the IT department. And it provides organizations with 4 core capabilities. So the first one is storing and retrieving data. So now, as an organization, whether we are a retail or a university, we need to store data about our customers, about our inventory, about our sales, right? We need to store that data in a database management system, such as Oracle, DB2 from IBM, or Microsoft SQL Server, right? Or MySQL, or as simple as Microsoft Access, right? So those are relational database for transactions that we need to store it at. Not only needing to store it, but we need to retrieve that data so we can create our analysis, we create our reports, dashboards, right? We retrieve data using structured query language or SQL. And SQL is one of the top skills that are sought after by employers, besides Python, R, and Tableau/Power BI. So those are the top 4 skills. Again, those are SQL, Python, R, and Tableau/Python or Power BI, right, for data visualization. So that's the first core capability business analytics or information systems provides to organizations. Second one is analyzing and visualizing data. So now we have retrieved that data. Now we can analyze it by aggregating that data, creating pivot tables, summing it, deducting it, finding out the maximum, the minimum, the average, and so on, in order to transform that data to useful information, right? So by analyzing that data and visualizing that data using some of the software like Tableau that we cover in our program, or as simple as Excel for data visualization, right? And then the third core capability is automating data processes or operations. That's where AI or machine learning comes into play. You use data or you automate data and decisions, right, through machine learning or artificial intelligence. And you can use Python for that automation. You can use R, you can use any programming languages, but those are the 2 main ones, right? And then last but not least, you need to protect that data, right? Protect the privacy of that data. So you can think, as you can see here, I have a heart in the middle of those 4 quadrants. So you can think about the capabilities and the functions of a business analyst as the function of the heart to the organization or to the body, right? So a business analyst team or unit will play the role of the heart to the body. So the heart receives the blood that doesn't have oxygen from all organs within the body. Then it feeds it with oxygen, redistributes it to the other organs so they can benefit from that oxygen and that food, right? The same thing for business analysts or information systems. We received raw facts or data from all units within the organization. Then we store that data, we retrieve that data, we analyze that data, we visualize, we automate that data, and secure that data so we can transform that data to useful information, and we redistribute it to the other units of the organization so they can make decisions that help reduce waste, improve efficiencies, and at the end of the day, to make decisions that will improve our bottom line profitability. So in the early 2000s, the World Economic Forum introduced this term, which says oil is the new data, or data is the new oil, actually. So data is the new oil. So it is just like oil. If we have oil that is sitting in the backyard of our house doing nothing, it is useless, right? So the database, for example, for crude oil, we need to extract it from the underground, and we need to take it to a refinery so the refinery can transform that crude oil to useful materials like gas, plastic, asphalt, just kind of to name a few. The same thing for data. If it is sitting, piling up in database management systems, doing nothing, then it is useless. So we need to retrieve that data from those piles or database management systems using SQL and take it and process it, transform it by analyzing and visualizing this data. We transform it to useful information. And then that's where the value comes into play. So you can think about analytics types. We have 4 analytics types. The basic one, which is 70% of organizations actually do, is descriptive analytics, which is telling us what is going on up until this moment, right? And then diagnostic analytics, that's where you drill down, you dig deeper Why is this? Why is, for example, the average age of our patients that were admitted last night was 65, right? Why was that? Is it because there is a widespread of COVID in this area? So the dig deeper or diagnostic is to understand why do we have that number, right? And then we have predictive analytics. Predictive analytics here is based on historical data, data that we already have in the past. We have examples of input, characteristics, for example, and we know the output from that data. And we know we ask or we train a machine learning algorithm to learn from that historical data so it can predict for us in the future. And I will give you examples, and we will do examples today actually using predictive analytics. And the last but not least is prescriptive analytics. This is where you prescribe solutions. What is the optimal solution for a problem having certain limited inputs or resources? How we can maximize our output with having limited input resources, right? And that we call it optimization, just as an example. So in this graph, you can see that 70% of organizations, 100% they collect data, right? And then only 80% prepare that data process, kind of, prepare that data, clean it for analysis, and 70% they visualize, they use business intelligence. So in other words, this is kind of confirms what I was talking earlier about. Descriptive analytics, 70% of organizations use that and they stop there. But when it gets to the data science, the machine learning, artificial intelligence, that's the next mile, which we call it the 30%. And even from that 30%, only 5% use that output for taking actions for decisions, right? So where would data analysts work? The majority of data analysts work in the IT industry, like Facebook, Apple, Dell, just kind of to name a few. And then they also work in financial services, banking, they work in marketing, they work in healthcare. Actually, here in the Valley, a lot of our graduates work for it, DHR, and also financial banking as well. So they work for consulting, for corporate, and they are not limited to only those. Those are just kind of the most common ones, but they work in now with the advent of AI, which is one thing that I always use as a motto. So for AI, if you don't, or my motto for AI says that AI will replace your job unless you learn how to work with AI. So no matter what your job is, if you don't learn how to work with AI, it will replace your job. And I will give you an example later on how AI or artificial intelligence can replace jobs. So what is the average salary for data analysts, data scientists? So as you can see here, around 75, the starting salary, and I have a friend, actually, he graduated from another university and he started with 75. And I have one student who sent me an email. She was still a student at that time, last November. She sent me an email. She said, Dr. Mokbel, I just wanted to thank you for admitting me into the program because I had a music background before I joined the MSBA program, and you admitted me into the program, the MSBA program. And I also wanted to thank you for teaching me Tableau, because I just received a job offer as a Tableau developer, and they are offering me $100,000 salary. So those are kind of the opportunities that students get when they are in such a field. So this is the way to go nowadays. So when students actually graduate from our program, we make sure that they have those goals or outcomes with them. So the first one, students will be able to solve business problems, not only limited to healthcare or security industry, but the skill sets that they learn from our program are transferable. So they can actually get into any industry and they will be able to excel. Second, they will be able to master analytical tools like Python and R. Those are open source programming languages, and they are highly sought after by employers. If you know those, because you are going to save your employer a lot of money, because if they let's say get you a license, only one license from SPSS, Modular or SAS, that can cost up to 2,000, maybe more per license, right? But Python and R, they are free, open source. You can do the same analysis and even more with for free, right? So Python, R as programming languages. We also teach Tableau, and we'll provide students actually with free licenses for Tableau to use, as long as they have the .edu email. And then SQL. We teach SQL in a couple of courses, so you will be very comfortable with SQL after you graduate from this program. So the third one, our students will be able to solve business problems using text mining, data mining, machine learning, social media analytics, enterprise analytics, and text mining. So in the past, we need to have numbers in order to be able to run analyses. But now with the advent of machine learning, we can use text actually for prediction, for actually sentiment analysis, for topic modeling, right? So an example of the use of text mining is, let's say that we have a call center, which I used to work actually in a major company, that we had a call center. And in that call center, we had two teams. We had the customer relations team that just deal with customer relations. And we had another team that is the technical support, the IT support, right? So we received tickets from our clients. We had more than 7,000 offices throughout the world. So we get sometimes tickets to solve problems for those offices. Those tickets, they need to be read by an employee and sort them out. This ticket is a problem about customer relations, so I will direct it to this team. This ticket is about IT support, so I will send it to this team, right? So that employee, we pay them at least $70,000 just to read those texts or those tickets and then sort them out. So now with the advent of machine learning or AI, artificial intelligence, we can train a machine learning algorithm model, such as neural network, which is used for self-driving cars, to learn from historical data, that historical tickets, and we already know where they were sorted out, whether they were in the customer relations or the IT support. So we feed that, we train that model from that historical data. That way, when we receive a new ticket, we plug it into that model, and it will tell us with high accuracy rate whether it belongs to the customer support, customer relations, or the IT support. So that's how IT or AI or machine learning or AI replaces job. So that person lost his or her job, but the best way for that person is to learn AI so they can actually be elevated to a better, more valuable job, right? And they can do better. So that's just an example of text mining. So the fourth outcome, so our graduates from our program will be able to work with data preparation, storage, and visualization. So data preparation, from any analyst or data scientist you will talk to, they will tell you that 70% of the time of data analysis is spent on data preparation, because you need to clean that data, you need to create your own variable, for example, or you need to do binning. So you need to do a lot of cleaning to that data, preparing before you run analyses. And last but not least, this is a very important outcome, which is storytelling, communicating your outcome, your analyses. Actually, I met with major employers, including Accenture, consulting company, and so on, and they were emphasizing the storytelling skill set that of students who graduate from such a program. And they emphasize that very highly, and we cover that in our program in several classes, and more specifically in my data visualization course. So this is just an example of a life cycle of data analysis in a healthcare. So what is the life cycle of one example of a use case data analysis in a healthcare system? So first we start with the problem. What is the problem that we are trying to solve, right? So let's pick this one, which is fraud detection, right? And then we start from the bottom up. So for fraud detection, we need to collect data from different sources, internal to the company or to the hospital or external. So then we integrate those data sources using what we call it ETL, extract, transform, load, into a data mart or a data warehouse. And then from there, we need to make sure that this data is secured. Then we can run our analysis. We can do queries like ad hoc queries using SQL, structured query language. So for example, what is the average cost per patient, right? What is the average, revenue per patient? So now we can see the cost and the revenue, and then we can calculate the profitability, right? Or something like that, right? So that's kind of what we mean by queries. First, just to understand, which is descriptive analytics. We can do create reporting, create dashboards, right, for our staff to see the, and also for our higher up managers. We can create business intelligence reports. We can even create predictive analytics, whether using machine learning, right? So this is just an example in a healthcare, but those are the software that we cover in our program. For example, the R, Python that I mentioned, Tableau, and also SQL Server. SQL Server, one of the classes, which is the data warehousing course, would provide students access to a virtual machine. So you will be able to have access to that actual SQL Server without having to install it in your machine. And then this is just briefly about our curriculum. So our Master of Science in Business Analytics requires you to take 11 courses only in order to get full master's degree, right? So 11 courses, each course is 3 credit hours. We have 8 required or core courses. Those you must take. The ones that they don't start with an asterisk, and the ones that start with an asterisk, that means they are electives. You need to select 3 from them, right? So if you want to concentrate, for example, in healthcare, there are 3 prescribed courses, include healthcare analytics, tools for managing healthcare data, and health computer information systems. That's if you want to concentrate in healthcare, but you are free to take any of those electives. And this program can be finished as early as 1 year if you take 2 courses every 7 weeks, because it's accelerated, or you can take 1 course every module and finish within 2 years. So we don't have a preference. Whatever works for our students, that's what we work with, right? So I have some information here about application, how to apply. I can share with you the slides after this meeting. I will send an email with the recording and also the slides if you need more information. And this is about the cost of, usually I took those slides from Samuel that you met outside the room. So the cost of the program is $15,500, whether you are international student or local student. So there is no out-of-state or in-state tuition. And also the university sometimes, all the time actually, has at least 1,000 scholarship for new students, and the application fee is waived. When you compare the tuition from our program to UT Austin, for example, or UT Dallas or SMU, that they I mean, they go more than 50,000, 45,000 for the same degree. And our program, as you can see here, our classes, they were designed for this particular skill set. Other programs, sometimes they recycle some classes from the MBA program, like marketing or management, and they add them to the degree, and they give only 1 or 2 analytics related. But our program, it is all hands-on. So the classes, we train you how to run analysis, and we throw at you data set and tell you, okay, now we showed you how to run analysis, now it's your turn. Show us what you learned, right? It is all hands-on. It's not like the majority of online classes somewhere else where they give you, go read the book and do a discussion, a post, and respond to 3 people and agree with them or don't, right? So we don't do that. So our program is all hands-on skills. So in this slide, You can see that I have my contact information, Maria. She's our staff over there. So thank you for your help with the setup here. And also Samuel that you met outside. So I have the contact information here, and also Grad Central. They are very helpful if you have specific questions about admission, if you have any questions about that. So having said that, now we are going to go through what machine learning is, and then we will go through a demo. I assume that my friends online, they already have Orange open. We are not going to start right away. Just make sure that it is open and ready. But before we start working with Orange, we need to know kind of housekeeping skills before we get into the machine learning and data mining and AI. So machine learning consists from its name. The machine learns. We train the machine to learn from data that we feed it with, right? So we have supervised learning and we have unsupervised learning. So before we get into more details about supervised machine learning versus unsupervised machine learning, we need to understand very basic information about the types of variables, the types of data. So we have continuous or numerical data, and we have categorical data. So numerical data is the data that is continuous or integers that we can add, we can multiply, we can divide, right? And then we have, which is like height, weight, sales, age, you are familiar with that, numerical variables, right? And then we have categorical variables. Categorical variables, they are classes or categories or groups. They can be nominal or ordinal. So an ordinal categorical variable, from its name, there is order implied in it, right? It is categories, but there is order implied in it. We call it ordinal. So what we mean here by ordinal, as an example, would be classification of students when they start their undergrad. They start as freshman, sophomore, junior, senior. So they are categories or classes, but there is rank. Freshman is not like a senior. There is a rank implied, so we call that ordinal, right? And low, medium, high, that's just another example. But for a nominal, that they are categories, but there is no rank implied, like gender, male or female, or colors. There is no color better than other color, right? They are all in that same category. So having said that, now we will get back to the machine learning, supervised machine learning. So supervised machine learning is that when we have a target variable that we already know from the past. So let me give you an example. Let's say that you are a bank, and in the bank, you usually receive applications for loans. And in the past, you already have several customers who applied for loans, and you already know whether they defaulted on their loan or not for those historical data, right? We already know their characteristics, for example, their age, their race, their gender, their income, their credit score. So we have a lot of characteristics about them. We call them features or variable or predictors, right? So we know all of that, all the input about them, and we know also the output, whether they defaulted or not. So that's something that we already know. So now what we do is we train the machine learning algorithm like neural network or logistic regression to learn from that historical data, the patterns, and it learns that from that historical data. So that way, when we have a new customer now, we plug in that characteristics of that customer, and it will tell us with high accuracy what is the probability this new customer will default in their loan or not, based on the patterns and trends that it learned from historical data. So it will have very high accuracy rate, and the probability will be right there above 50 or below 50. So as a bank, why do we need to know that? Because you might see that if someone is, the machine learning tells us, or AI is telling us this person is going to default in their loan. So you might choose to give them a loan, but with high interest rate, or give them a loan with not the amount that they requested, or just deny their application for a loan, right? So that way you can avoid risk. So this is how companies or businesses can benefit from AI or machine learning. So that's an example of a supervised learning, right? Another example, so that's when we have a problem that is classification. Our target variable is a categorical. So default or not default, that's categories, right? So whether they will default or not default. So that target variable there is binary or categorical. So what if we have a target variable that is continuous or numerical? So an example would be, let's say that we have alumni foundation here at University of Texas Rio Grande Valley. We have a lot of students who graduated from our program. Sometimes our foundation sends them emails or requests or mail, let's say, to ask for donations for scholarships for our students, right? And some they return and they give donations, some they don't, right? So based on historical data, we can train a machine learning algorithm based on that historical data, and it will learn from those patterns from that. And also it will tell us what is the probability and how much they are going to donate based on that characteristics, right? So now we have a new alumni just graduated and we are planning to send them a mail. We will know what is the probability this person and how much this person is going to donate, right? So now instead of sending, for example, 100,000 mails, right, or 100,000 might be too much, let's say 10,000 mails, assuming that it takes $1 for back and forth envelope with the return envelope. Now we can just send to 1,000 because we know those 10,000, they are the ones they are going to donate, and they are going to donate generously, right? We don't want to target and waste, not waste, but we don't want to spend money on some amounts that they are going to donate just very little amount, right? So, but you got the idea how we can benefit. And if the target variable is the amount of money that can be donated, that's what we call it estimation or prediction. And the one that the target variable is categorical, we call that classification problem, right? So those are the ideas for unsupervised learning. We have, when we don't have a target variable that we are really looking for, right? So an example of the unsupervised learning will be association rules, clustering, data exploration, visualization. Let's focus on association rules as an example for unsupervised learning. So association rules, from its name, we look at the association between, for example, the sales or the happening of two events. So association rule, other name for it is market basket analysis. So all of us, we buy products from Amazon. Sometimes you buy a product and then Amazon tells you people who bought this product also bought this product. So that's what we call it here, unsupervised learning association rule analyses, right? Also, we watch movie on Netflix, and then Netflix tells us people with your characteristics who watch this movie also might like to watch this movie as well, right? Something like that. So this is what we call recommendation system, and this is based on association rules. So there is a story about association rules that I'd like to share with you. So hopefully that can help you kind of remember. So there is a major supercenter in the Midwest region of the United States that conducted unsupervised machine learning analysis using association rules in their supercenter. So what they found is that the sales of baby diapers are associated with the sales of beer. So you might think, what is that? What is the link between baby diapers versus beer? So what they did is they said, well, now let's look at diagnostic analytics, right? We want to know why. So they dig deeper. They interviewed some of those customers who bought those two products at the same time. And they found out those people who bought those baby diapers and beer at the same time, they were young adults who just had a new baby. They used to go to the bar before they had the baby to drink and relax after work and go home, right? But now they had a new baby, they can't take the baby with them to the bar. So instead they go buy the baby diaper. They say, I might as well get a pack of beer and drink at home while I'm enjoying my time with my baby, right? So as you can see, this is very interesting analysis from using data mining. But how can we monetize it? That's what we're really interested in as a business, as a retail business. How can we monetize this finding? So what they decided to do is that they wanted to place, or they placed actually, the aisle for alcohol very close to the baby diaper location. And as a result, the sales of both products went exponentially high, right? So this is not about Walmart, but if you go to Walmart, I want you to go to the back wall of the store, and you will see next to it, actually, the alcohol aisle is very close to it. So again, no, this story is not about Walmart, but when you go to Walmart, just keep that in mind, right? So having said that, now let's look at the process of data mining. So IBM, they are the pioneer who came up with this standard for processing data mining. So what they did is they told us the first thing that we need to do when we are working on a data mining problem, we need to define what is the problem that we want to solve, right? And then obtain that data, you might need to do some random sampling. And then you need to explore that data. Maybe there are some outliers, there might be missing data and so on. And then reduce that data. Sometimes you might have more than 100 columns, right? And you want to predict whether they will default or not, but you have 100 columns. You don't want to use all those 100 columns about a customer or collect all of those, right? You want to focus on a reasonable amount of columns, maybe in the tens, right? Not more than 100, right? So, and we call this feature selection, which reduces our number of columns, that as an example. And then if we have supervised data mining, machine learning or supervised learning, then we need to do partitioning. So when we want to run classification analyses or prediction analyses for estimates, continuous versus categorical target variable, we need to partition our data set into training data set. That is usually 60% of the data set that we have is for training our model. And then we use 40% for testing our model, right? So we need to use different partition of the data. So to make sure that our model is not overfitting. So overfitting, when we train our model with the 60% and we try to train, to test it with the same data, it's gonna predict it 100%. But if we partition, 60% we train the model, the machine learning to learn from this 60%. And then the 40% we will use it as testing if our model is performing well or not, right? And then specify the task, whether it is classification, estimates, clustering, choose the technique, whether it is logistic regression versus linear regression. So remember now, when we had categorical variable as our target variable, we can use logistic regression as one of the machine learning. And if our target variable is continuous, we use linear regression as one of our machine learning algorithm. So you can't switch them. That's one thing. Linear is for continuous, logistic is for categorical target. And you will see now when we do the analysis in a little bit. And then some they go even further to tuning that model. And then we assess the results. We have multiple machine learning algorithms that we test. And then we pick the best performing algorithm, and we use that for our future prediction. So that's where we deploy the best model. So now pre-processing the data, again here, I want to emphasize the numeric versus categorical variable and partitioning. I already talked about it. Now data mining with Orange. So Orange is an open source software that was developed by scientists from Slovenia, which is in East Europe. And it was developed, actually it is based on Python, and it has some library of C++ objects. So it was developed in 1997, and they have been developing it and improving it. And again, it is an open source, it is free. It is GUI, which means graphical user interface. You don't need to know programming, how to type scripts, right? So now you can just drag and drop the widgets, and we will do some examples here in a little bit. So this is kind of the interface, the user interface, how you can start a new project, you can open all projects that you already saved or recent, and they have nice tutorials on YouTube channel. I also have several tutorials that I started. I've received a lot of comments and sometimes requests. Although my YouTube channel is not for profit, I don't make any money or hits because my videos are for education purposes, and I don't actually and I don't have a million hit for any of my videos, so, right, which is the requirement for YouTubers. So there are some examples also here. So for example, one of the examples here, we will see if we have the chance to do it, is for classifying tweets by Hillary Clinton versus Trump. So you can use text mining to predict whether the tweet is by Hillary or Trump. But some of the examples are here. And this is the user interface of Orange. So all of you have Orange open now. And so the first tab here, data, it has some widgets that we are going to use. We are not going to use all of them, but the ones that we are going to use is the file. And we will use the data table. We will use the ranking, which is for the feature selection. And then for the next one, for visualization, we will use just, distribution to understand our data, how it looks like. And then for the models, that's where the machine learning algorithms we are going to select from. There are a couple of them. There is the decision tree, K to the nearest neighbor, random forest, linear regression, logistic regression, neural network. So those are some of the algorithms that we are going to use today for the example. And then there is unsupervised learning, but we will not get into the unsupervised learning. We will use the evaluate here. We will use test score, prediction, and the confusion matrix. So let's look at this data set, which is an example that we are going to use today. It is a data set that is already provided to us in this software. It is called the heart disease data set. It is the target variable in this case is whether the patient has heart disease or not. If they have a narrowing diameter, that means they have heart disease. If it is not narrowing, then they don't have heart disease. So who can tell me whether this is classification problem or estimation problem? So the target variable is the presence or the absence of heart disease. This categorical. So in this case, is it classification or estimation? Classification, perfect. Because the classification is when we have classes. So in this case, we have the class of the presence of heart disease and the class of not having heart disease, right? As our target variable. Perfect. So those are some, this is our target variable. And then the rest, they are our features, which means predictors. We use those characteristics to predict whether this person or patient will have heart disease or not. So an example of the attributes or features include cholesterol level, chest pain, maximum heart rate, age, gender, and so on, right? So we'll skip that. And this is how, when we import the data, this is how it would look like. And this is, we call this in information systems or in analytics, we call this a data dictionary or data description or metadata. So metadata means data about the data. right? So now this is data that explaining our data. So it is telling us the name of the variable, which is, for example, age, and the type of it is numeric. Again, numeric versus categorical. That's what we emphasized earlier. So now you know why we were emphasizing numerical versus categorical. So age is numerical data type, and the role here is very important. What is the role of this variable? Is it a feature, meaning a predictor, or it is a target that we want to predict, right? So, and then the values of it. So for example, gender here, it is categorical, it's a feature, and it has male or female as its values, and so on, right? But our target is the diameter narrowing, and we assigned each role as target. That's very important. And then we explore our data. We can actually look at our data, how it looks like in a spreadsheet format, and this is how it looks like. We're going to do all of this. This is just a quick preview, and then we can use some visualization. So visualization, you can think about it, there are two types. There is visualization for analysis purposes, and there is visualization for dashboarding and for reporting. So now we are talking about visualization for analysis purposes, right? And then we look at the algorithms that we have available. We have a couple of them. Those are just examples, and we are going to use logistic regression instead of linear regression because our output or target variable is categorical, right? Because we said linear is for continuous or for numeric, logistic is for categorical. And so we are going to, this is what we are going to build. So this is what we are going to build right now with our orange. Let's start working on this guy. So let me open orange. So the first step that we're going to do is to drag the file into the canvas. So we'll drag it from the data area. So I'll drag this file into the canvas here. So my friends online, I hope that you can see and hear me clearly. And I will try to go slowly. Okay, great. Thank you all. All right. So now we have the data file here. Let's double click on it. So that way we can see how we can import. So now this data is not the data that we want. It is about the IVs, right? So for us, we want the heart disease data set. So how we can get into our data set is by, again, double clicking this file guy, and then go to browse documentation data sets. All right, let's click on this guy, browse documentation data set. Okay, and then you will see a couple of data sets there. Let's look for the heart disease data set. Select it. All right, everyone online. I will double click, and then you will see the heart disease guy here. I'll select this guy and say open. All right. So for those of you who are online or you didn't get it, I'll try to do it one more time. This kind of, I know some people might take time to catch up. So we will do double click on the file and then browse documentation data set and then select heart disease and say open. All right. So now when we open, we see we can maximize this guy. That way we can see all of our variables. And as you can see here, we have the diameter is as set up as target, right? So we will not do anything. If yours look like this is great. If it is not, if it is showing them all as features, you can just click on this guy and select target, just in case, if it is not, because we want to make sure that this one is called target, because this is what the one that we want to predict. All right, so if we are done, we'll just apply and close out of this. So now we have, okay, great. So now we have that file. Now let's say that we want to see how that file look like in a spreadsheet form. Yes. That means you are all set, but do you have this at target? Okay, great. So you can close out of it because you didn't make any changes. That's why it is grayed out. Mine, because I clicked on it and then I selected it again, it was not grayed out, but that's good. Very good point. Now let's say that I want to see the content of this file because all it showed me here is metadata or data dictionary. And I'm not interested in that. I want to see the exact content of it. So to do that, I need to drag the data table and drop it somewhere here. All right. So, and then I need to connect. So by dragging this front to the back, so I will just, I will connect the file by dragging this guy, to this place. Now I can double click on the data table and you will see how my data set look like in a spreadsheet format. I have the diameter and I have the values for every patient. So every patient is a row and every column is a feature. All right, so we are good with that one. Now the next thing that I wanted to show is something we call it feature selection. So remember when we said if we have hundreds of columns, we need to narrow it only to a reasonable amount of columns. So that's where the ranking comes to play. So we'll drag this ranking, drop it here. And then again, I will connect my file to the ranking. And I will double click. So if you see that exclamation mark, it should not be a problem. So just double click on this guy now. Now it will show us this window. So this window here is telling us the importance of the variables in terms of predicting our target variable. So the importance, the longer the red, the more important or the more it contributes to the prediction of our target variable. So as you can see here, the least important variables is cholesterol, fasting, blood sugar, although a lot of, I don't want to get into this, but a lot of people tell us that if your cholesterol is high, you might get a heart disease. So at least this data set tells us that cholesterol is not a contributor to heart disease. So I'm not challenging science, but at least this is the data is telling us here, right? So now we have seen how the data look like. And this file also, you can import your own data set. So for example, that you have a new data set that is, you don't want to use some of the ones that are here. You have your own data set that is stored on your desktop. You can click on this guy. So let me, you can click on this file here and then navigate to any, for example, your desktop or anywhere, and then select whatever file that you have there, whether it is Excel, CSV, or any type, right? You can upload your own data set and work with it from there. So that's one of the really nice features of Orange. So the other thing, so now we are done with the data tab. Now let's move to the transform. In the transform tab, that's kind of really nice workflow, right? We start with the data, then we go to the transform. So for the transform, I need to select the data sampler, which is this guy, the data sampler. I will drag it and drop it here, and I will connect my data to the data sampler. Right. Now for the data sampler, remember when we said partitioning our data set from 60-40, or some people they do 60, and then yes, some they do 80-20, some they do actually they do even 3. They do training, validation, and test. So they do it like even that way, maybe 50 training, 30 validation, 20 test. But for us in this case, we will do maybe 60-40. You know, it's up to you how you want to partition the data. But let's see here the default. The default is 70, 30. So what about you guys? Do you have it as 70%? So we'll keep it the default. That way we don't get confusion, right? We'll just keep it as 70. But for me personally, I use 60-40. All right, so close out of this guy. And then, so that's one thing. Now let's move on to the next step, which is the visualization. So visualization here is just kind of describing for us our data set, just to explore something. So in this case, let's use the distribution and just put it somewhere, maybe here, somewhere here on the top. And then connect our file to the distribution. And then you can double click on the distribution. Now you can see that in terms of age. So again, 1 is the presence of the heart disease, the 0, which is the blue, the absence of the heart disease, right? So among elders, they tend to have more, heart disease, but the younger, they don't have heart disease, which is kind of common sense, right? And then in terms of gender, males tend to have more heart disease than females. So that's kind of how we understand the data and explore it, right? I will close out of that. So now let's move on to the next tab, which is modeling, the model. So the models now, we can drag the ones that you feel comfortable with, and you can even, explore more. We have the help function here. You can learn more about the algorithms if you want to go further. But for us, we will just go, for the sake of demonstration, we will go with the K to the nearest neighbor. We will use decision tree. I will use random forest. So let me put them here. That way they kind of, they are in the workflow. So K to the nearest neighbor, decision tree, random forest, and let's say, so linear regression or logistic regression, who can remind us? Yes, linear is numeric, logistic is categorical. So since our target variable is categorical, we use logistic regression. Perfect. Logistic regression. If you try it, you use linear by mistake, for example, you will see that there is a question mark or some warning telling you, no, 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 and then you can delete it, right? So that's a great thing about Orange. And then let's use neural network as well as our last one. So neural network is here, just drop it here. Okay, I'll try to, so I'll try to just kind of to move them that way. You can see my screen clear. I will leave the logistic regression till the end because I already kind of know which one is the most the highly performing algorithm, but we'll see. So now we have all those algorithms. Now this is optional. You can connect the data sampler to the algorithms, or you don't have to, but let's connect them. Let's connect them. So we'll connect the data sampler to each of our algorithms. All right. So now we are done with the data modeling. So now let's move on to the evaluate. So in the evaluate, I need to have the test and score. So now it is time for me to test and score my algorithms. All right, I'll put it here. So test and score. I need to connect my data sampler to the test and score. Right now I have data sample. I have only one line. So I need to double click on this guy. Yeah, it's very similar to Access database. Yes, when we connect the relationships. Right. So now for data sampler to test and score, let's double click this line between them. Right. So when you double click on it, you will see that data sample is the data, and the remaining data, remember when we partitioned 70-30, now it has the 70 to connected to the data, but the 30 is not connected. So what we will do is we will click on this one and drag and connect it to the test data. Everyone is good? Online, if anyone wants me to do something, please put in the chat, and then I can redo one step if I'm going too fast. All right, so I'll yes, so this one, I double click on this line, and then I connected this guy to this guy, and then say okay. Now you will see that we have double line, right? So we have one remaining data, one test data, right? Perfect. So now we have that. Now it is time for us to connect our algorithms to the test and score. So let's connect one at a time. Wait. When we are done, now let's click on test and score. So for test and score, now you will see that we have multiple performance indicators. So those will help us kind of to tell us what is the accuracy of our algorithms in prediction of the test or the performance of our model. So now if you see in the left side, we have cross-validation. That's one method of validating our model, how accurate it is. But for us, we partitioned it 70-30, and we said we want to test in the test partition. So in other words, I need to select test on the test data. So the last option, test on the test data. So that's what we want, right? We trained it with the 70% of the partition of the data. Now we are testing the 30%, right? And this performance here is showing for the 30%. And now what do those guys here tell us? Which one should we look at in terms of performance? So this guy is called classification accuracy rate. And this one, the area under curve. So the higher the area under curve, the more accurate or the higher the performance of that algorithm. So now we have different algorithms here. So can you tell which algorithm is performing better? The logistic regression, because the area under curve is almost, it's 91%, right? The highest can be 1%, right? Or not 100%, right? So this one is 91%. So now the algorithm that we want to deploy is actually the logistic regression, if we want to do that, right? So now that's one thing. Now, remember, I told you I want to show you the confusion matrix. The confusion matrix helps us kind of to validate our results, or which algorithm is actually performing more or well. So let's click on this guy. So the ones in the rows, that's the actual data, right? So the actual data. And so the actual data, it has 43 that they have the heart disease, and 47, at least from the test data, and 47, they didn't have heart disease. But the predicted data, so the predicted data that we create, we were based on the K to the nearest neighbor, said that predicted 33 to have heart disease and 57 to not have heart disease. So we already know K to the nearest neighbor was not one of our best performing algorithm. We said logistic regression. So again, now, before we go to logistic regression, now we want to say what do we really mean here by those quadrants? So this 19 guy, we call this true positives, the true positives. They were accurately predicted. 19 were truly predicted to have heart disease, so we call them true positives, right? And the 33, we call it the true or the true negatives, right? The true negatives. So now, what about this guy here? This one and this one, we call them misclassification. They misclassified. So our prediction says those 24 they don't have heart disease, but in actuality, they have heart disease. So they misclassified 24. They said they have heart disease, but they don't, right? We call this misclassification. The same thing for this 14. The actual, they don't actually, they misclassify those 14 to have, actually they predicted them. Yes, those ones here, they predicted them not having heart disease because it is 0, but in actuality, they have heart disease. This 114, they predicted, our model predicted them to have heart disease, but they don't have heart disease in actuality. So this is what we mean here by misclassification. So if you select misclassified, it grays out those misclassified. So now if you count the misclassification, how many? They are 8, so 38. That's a big number to misclassify out of 90. So now let's click on the logistic regression and see how much they misclassified. Instead of 38, now they misclassified only 12, right? So that's really good, much better, right? So now that's what we mean here by the confusion matrix. It's not that confusing, right? So now we are done with training our model, right? We trained our model. Now we are ready to use it for future data, right? So now let's say that we have received a couple of patients and we want to predict whether they will have heart disease or not based on the characteristics, right? We haven't done any testing about narrowing or not, but we want to predict if they will have a narrowing or not, right? So they will have heart disease or not. So let's create a new, we'll go back to you can go to the data, or you can just right click and type data, or actually type file, because that's what we want. Type file, and then select that file. So this is one option. Or you can go to the data widget, category, and drag and drop that file from there, right? So now for this file that I have as file 1, I need to double click on it. Again, now I will navigate to browse documentation data set, and I want to select the heart disease and say open. All right, so now you can expand or maximize this window. Now I have new data, right? This target is not relevant to me. I need to change this target and change it to meta. Meta means it is data about data, right? Meta, in other words, the role here, meta, it is just, I'm not using it as a feature for prediction, right? I'm just using it for the sake of describing my data, right? I'll just leave it as meta and say apply. So everyone is good? All right. So then I will apply. So just kind of to double check with everyone online, what we did is, what we did is I dragged this file to here, then double clicked on it, went to browse documentation, select heart disease, and then I changed this guy to meta instead of target and apply. All right, so now I am going to use this one as my new data, as if I have new patients and this is their characteristics, and I want to predict using my machine learning or the AI that I already trained, and I wanted to predict. So now I need to go to evaluate, to the evaluate category, and I need to use prediction. So this guy called predictions, I will drop it here. And I will connect my file 1 to the prediction. And now who can remind us which algorithm was our favorite or most performing model? The logistic. So now all I need to do is to drag my logistic into the prediction. So that's all I need to do is just to drag and connect my logistic regression algorithm, which is the one that I already trained, and connect it to prediction. Now I can double click on prediction to see what, for example, this patient whose age is 63, it is male, and so on, right? I have all this data. Cholesterol is 233. This person will have heart disease or not. So logistic regression is telling me no, this person will not have heart disease, right? So now I can use even this one, drop down classes known to the model. So it tells me the probability even, right? So this, for example, if I'm a bank or even a hospital, I see kind of how close to accurate it is. If it is close to 50, that means I'm taking risk, might not be as accurate, right? But now this one is telling me, so this is the prediction, and this is the actual. So now can you see how accurate it is actually by comparing what we predicted using logistic regression, and this column here is the actual data. We already know that this person, for example, doesn't have heart disease. Our model or our AI here predicted it not to have accurately. The same thing. So it misclassified. Maybe if you try too hard to find some that were misclassified, rarely you will find this one, for example, was misclassified, right? It is actually, it has heart disease, but here our model is telling, but those are one of the 12, right? So we have 12 in total that we're not. So you got the idea now. This is one way to create an AI, or you train a machine learning or an AI to learn from historical data so you can use it for prediction in the future. So that's for classification. So if you are ready, we can do one for numeric outcome. Would you like to do that? Everyone? All right, so let's do that. So this one, we can save it, or you can do anything you want with it. So for me, let's say, I'll just put it here. And I will start a new one. So for this new one, it is called the Boston data set. Boston housing data set. It is well known if you go to any of those analytics websites, you will find it, right? So we will do the same thing. We'll drag this file, double click it, and we will go to browse documentation data set. And we will find the housing, which is the third data set, right? So I'll say housing, and then I will maximize. So now you can see the features and the target. So the features here include the crime rate, they include the zoning, industry, the age of the house, the distance, the tax, and so on. So they have several features or predictors that they use. So what we are interested in is predicting a numeric variable, which is the median or the value. So the median value in thousands, right? So it is numeric and it is our target variable. So we are set. We don't need to make any changes for this side. Now we need to go to the transform and do the data sampler, connect our data file to the data sampler. And then now the next step, do we need anything from here? Not, right? Visualization, do we need, we can skip that, right? We don't need visualization, just kind of in the workflow. Now we need to go to the models. In the modeling, we'll drag and drop our algorithms. So let's just drag and drop some of the ones that, so K to the nearest neighbor decision tree. and then random forests. Now linear or logistic? Linear, perfect. So linear, and then neural network. All right, so we'll do the same thing. Just connect those guys. Again, I said those are optional, but it is good to do it because whatever is our favorite or our highly performing model, we can use it for prediction without problem. So now we move on to the next, the evaluate. So we'll use test and score and connect our data sampler to the test and score. So what should we do now? Can you remind us? Yes, double click on this line so we can connect our remaining data to the test data. Perfect. So now we have our connection for the training versus the testing partitions. Now let's connect K to the nearest neighbor or our algorithms with the test and score. Don't worry about that exclamation mark. Yes, so this one, so data sample to data and then remaining data to the test data, right? Like this way, perfect. And then we say, okay, that way we have parallel lines. So we're good, perfect. So now we'll just connect the algorithms to our, to the test and score. Now let's double click on test and score and see our performance here. So now there are different ways you can look at the performance of our models here. You can use R-squared, which is kind of the traditional way of evaluating linear regression, is looking at the R-squared. So the closer to 1, the better. And another parameter for evaluating our algorithm's performance is the mean square error. The mean square error. So the lowest the error, the better, right? So that's kind of from the ones that we can use the mean square error, the lower the better, or we can look at the higher the R-square. So now it doesn't look like it is in order, but we can click on this guy. Now the R-square is the highest for random forest, and also the mean square error is the lowest for the random forest. So now we can say that random forest is the most or the best performing algorithm in our sample. So again, that's for the cross validation. But now remember we said we want to test with the test data. So again, we need to test on the test data. So we need to select this guy. Let's see if that still holds. It looks like it still holds, right? Yep. It still holds even when we test with the test data, right? So now I selected test on test data, and we still have random forest is performing highly as a machine learning algorithm. All right. So now we have that. Now can we test new data? Let's say that we have new houses in the market and we want to see what is their value, right? In thousands. So we will do the same thing. I will just right click and then type file, click on it. I'll double click on this guy and I will browse documentation data set. So I want to go to the housing data set, say, okay. Again, this guy, I need to change it now since I am using it for prediction as a test data. I need to change it to metadata and apply and close this guy. If I'm going too fast, my friends online, let me know. Okay, so what I did is I dragged this file one, double clicked, browsed for the housing data, clicked open, and I changed this guy the role from target to meta and then apply. Then I close this guy. So now I need to use the prediction. So the prediction, I need to drag it and drop it here. Connect my file to the prediction. And now which algorithm was performing the best? Random forest. So now I'll just drag my random forest to prediction. Now I can click on my predictions. And now you can see how accurate, how close to accurate the values of the predictions versus the actual value. So for example, here, our model predicting the first house to have a value of 26,000 or 26 in thousands, right? Or in 10,000s or so, versus this one, it says 24. The second one is very close, right? Second prediction is very close. Also the third, the fourth, but you got the idea, right? So now we trained AI to learn from historical data. Now we can use it to predict in the future. So another additional feature, if you want, let's say to save this output into an Excel file, right? So to do that, you can go to the data, or you can just right click and type save data, right? So connect your prediction to the save data, right? And then double click and then save as. And then here in the bottom, save as type, select Microsoft Excel spreadsheet, and you can put it somewhere, anywhere where you can find it, and then say this is housing prediction. All right, so now what did I call it? Housing prediction. So now when I open it, this is how it looks like in Excel. Let's see. So now I can use it. So this is the random forest prediction. And I can use this as a business. I can use this one for my prediction, right? So that was kind of briefly about data mining, machine learning, artificial intelligence. I hope that you learned something from here. And any questions for me? Yes, this is open source, it's free. And so you can download it for free. It's called Orange Data Mining. And then you can, yes, and you can play with it. And then if you want to get into more details about machine learning, about I would recommend that you get into, because sometimes you might think about taking a MOOC class, you know, those free classes from edX or from, right? Sometimes we do that and we work on it for straight 2 hours and then we get bored and we never go back to that class, right? So that's one thing about those MOOCs. But if you take a degree, preferably with us, but if you didn't take it, you know, with us or with any other program, it gives you that commitment because you work with groups, especially our program. We have, it is an online program, but the majority of classes, we have groups. So you work as group and you get connected with the groups and you learn from each other. The majority of our students, they are already, for example, one is a data administrator, one is a data scientist, but they want to get the full spectrum of analytics because they are focused only in the machine learning, but they haven't done Tableau, they haven't done business intelligence, right? So the great thing about being in a class and in groups is you learn from each other. And I have one of my students, she came to talk to my classes, to my class last spring. She graduated from our program and she worked for the Fortune 500. After she graduated from our program, she got that title as a data scientist because she really learned a lot from our program. So I invited her to come and talk to our class, and she said, I learned so much from my classmates as well, and I'm still in touch with my classmates through WhatsApp. When I get into a problem in my current job, I just text. I know that person is an expert in this area. This person is an expert in that area. So you build your own network and you will be successful, you know? So that's kind of one thing that I wanted to share with you. And any other questions for me before we call it night? Yes, sir. Yeah. That's a very good question. I have a couple of students who work remotely. I had one student, she graduated, she was biology major, and she came to our program. She graduated from our program. She worked for DHR initially as an entry level. And then now she is working remotely for a better job, better pay, and it is remote. The same thing for my student who came to present here. She is from the Valley. She went to work for the Fortune 500 all over. She came back to the Valley. Now she's working remote, but still maintaining that status, right? So, but it's not guaranteed. You know, I can't guarantee, but your skill set actually will, if they see that you can bring something to the table, you have that, you know, I think remotely will work for this program, because everything you do is on the computer, is analysis. You don't have to be in person actually for this skill set. But that's a good question. Thank you. Any other questions? Yeah, sure.
What's your
Yes. So that's a very good question. It's very hard to collect that data. We are trying to follow our students who graduate. Yeah, we are trying to reach out to our students to see their employment. But so far, I have been I was reached out by some of our students who were struggling to, for example, to find a job. When they couldn't contact me, I also get requests from employers for, do you have someone you recommend for my position that I have? So that's one thing. And we have partnerships kind of with some informal partnerships with some employers here. And we have some alumni. They reach out to me and they tell me, you know, I have those two positions, but I need it. Some actually here within the university, they reach out to me. I have this position, but it's more about analytics. I want someone from your that you would recommend. Yes.
So there's a fun here and there. It is kind of getting to with so much people that want to know about this job. But you know, if you go out there and you create projects like this and you show them in the first place, and then for it to be able to know what you're going to do. So there's so much things that you can do. And you gotta do it yourself in your own time. It's really fun to show. I can do it. But that's what there is definitely. Yeah, like I'm honestly super interested in that, especially with 1 year. That's great. I'm only going to be, I have to go to a whole bunch of years, but I already have the knowledge, you know.
Yeah. Yeah, and if you have any questions, you have our contact information, and also Samuel, he's great. Oh, sorry, Garza said they can't hear the questions. So the first question was about the opportunity for remote work for students who graduate from our program. And my answer was that I have a couple of students who graduate from our program, and they were able actually to to locate or jobs that they are working remotely. One of my students was working for Fortune 500 when she graduated from our program. She got that title as a data scientist, and now she's working here from the Valley. And I always invite her actually to come and talk to my students. She's very helpful. Another student, she worked for a little bit because her background was biology, 100% in undergrad. She wanted to get into school medicine, I would assume, but then she wanted to do our degree in business analytics. She worked 1 year. I placed her actually with a local employer here for a few months, and then she got a better job somewhere else that is remote. Now she's working remotely. So, and then also one of our participants here mentioned that she's already a data scientist and she's interested in the program since it is 1 year. And that way she can get the full spectrum of the program. And also the networking is very important. Our students are very well, and our program actually has a lot of group projects. So you will be meeting with groups and those have diverse skill sets and you will benefit from each other. So any other questions? Yeah, if no more questions, we can call it a day. And it was great meeting you all. And again, this is recorded and I'm gonna share with you the slides and also the recording. So thank you all. And we'll be in touch with you soon. And again, if you have any questions, you can reach out to me directly. We can meet even on Zoom. And if you have specific questions and you wanna, I have office hours on Thursdays using the same link that you have every Thursday from noon until 1. You can just jump in. You don't have to even tell me. I have office hours for my classes and also my PhD student here, Mohammed. He also meet with me during that time. So if you want to meet and talk, you're more than welcome. All right. So, all right. Thank you all and have a great one, everyone.
Hello.